Welcome back to the Space Diary. Today we will continue our journey throughout the solar system. We're about to dive into the red planet Mars. Our celestial neighbor has captivated humanity for centuries, inspiring countless tales of science fiction and fueling our dreams of one day becoming an interplanetary species. But Mars is more than just a figment of our imagination. Join me as we peel back the layers of time and explore 10 mind-blowing facts about this enigmatic world. Our first stop takes us high above the Martian plains to the largest volcano in our solar system, Olympus Mons. Imagine a volcano so colossal, so massive, that it dwarfs Mount Everest 3 times over. This behemoth stretches over 370 miles wide, roughly the size of Arizona. Its caldera spans 50 miles in diameter. To put that into perspective, you could fit the entire Los Angeles metropolitan area inside. Olympus Mons is a shield volcano, formed by eruptions of lava that flowed for vast distances before solidifying. The low gravity and lack of plate tectonics on Mars allowed this volcano to grow to its incredible size over billions of years. Just picture the eruptions that must have sculpted this monstrous mountain, rivers of molten rock cascading down its slopes. It's a testament to the raw, untamed power that shaped the early solar system. While Mars may seem like a still and silent world, it harbors a secret weapon: dust storms. These aren't your average dust devils. These tempests are planet-sized monsters, capable of engulfing the entire globe and raging for months on end. Imagine a wall of red dust, whipped up by winds that can reach speeds of over 60 miles per hour, sweeping across the Martian plains. The sky turns a hazy crimson, blotting out the sun and plunging the planet into an eerie twilight. These dust storms are fueled by the thin Martian atmosphere and the planet's extreme temperature variations. They are a testament to the power of nature, a reminder that even on a seemingly barren world like Mars, forces of incredible magnitude are at play. Mars, unlike Earth, boasts not one but 2 moons, Phobos and Deimos, named after the Greek gods of fear and panic. These celestial bodies are much smaller than our own moon. More akin to large asteroids, their surface is scarred and cratered from eons of cosmic bombardment. Phobos, the larger of the two, resembles a celestial potato, measuring a mere 14 miles across. It orbits Mars at a distance of just 3,700 miles, closer than any other moon to its planet in our solar system. Deimos, on the other hand, is a diminutive world, barely 8 miles in diameter. The prevailing theory suggests that they are captured asteroids, ensnared by Mars's gravitational pull billions of years ago. Their irregular shapes and compositions, vastly different from Mars itself, lend credence to this hypothesis. Prepare to have your perception of scale shattered as we journey to Valles Marineris, a canyon system so gargantuan it makes the Grand Canyon look like a mere crack in the sidewalk. Stretching over 2,500 miles long, Valles Marineris scars the Martian equator like a colossal wound. At its widest point, it spans an incredible 125 miles, while its depths plunge a dizzying 4 miles down to the canyon floor. To put that into perspective, if you were to stand on the rim of Valles Marineris, you would need a telescope just to see the other side. Unlike the Grand Canyon, which was carved by the relentless erosion of the Colorado River, Valles Marineris is thought to be a tectonic feature, a giant rift valley formed by the stretching and cracking of the Martian crust billions of years ago. It's a sobering reminder of the dynamic nature of planets, even those that seem long dead. Our journey through the Martian landscape now takes us to a time when rivers flowed, lakes shimmered, and the planet may have harbored the potential for life. Scattered across Mars' surface lie tantalizing clues of a watery past, evidence of ancient floods that once raged across the planet. Imagine vast networks of valleys carved by flowing water, their channels etched into the Martian rock like the veins on the back of your hand. These valleys, some stretching for hundreds of miles, are clear indicators that liquid water once flowed across the Martian surface. Then there are the dried-up lake beds, vast depressions in the landscape that once held standing bodies of water. Some of these lake beds show signs of ancient shorelines, their edges marked by layers of sediment deposited over time. The evidence is clear. Mars was once a much wetter, warmer world than the cold, dry desert we see today. As we stand on the surface of Mars, we're greeted by a stark contrast to our home planet. The sky above isn't the familiar blue, but a pale, dusty pink. This is because the Martian atmosphere is a wisp of its former self, 100 times thinner than Earth's, barely clinging to the planet's grasp. And the air we breathe, a life-giving cocktail of nitrogen and oxygen, is nowhere to be found. Instead, the Martian atmosphere is dominated by carbon dioxide, a greenhouse gas that traps heat and contributes to the planet's extreme temperature swings. Without a substantial atmosphere to protect it from the harsh radiation of space, liquid water is unstable on the Martian surface. It's a harsh and unforgiving environment, a stark contrast to the life-friendly atmosphere we enjoy on Earth. Just like Earth, Mars experiences distinct seasons, but with, well, a Martian twist. Due to Mars's elliptical orbit and axial tilt, its seasons are twice as long as those on our home planet. Imagine a summer that stretches on for nearly 6 Earth months, followed by an equally long winter. During the Martian summer, the sun shines brightly, warming the surface and driving temperatures up to a balmy 70 degrees Fahrenheit near the equator. But don't let that fool you. As soon as the sun sets, temperatures plummet, plunging to a bone-chilling minus 200 degrees Fahrenheit at night. These extreme seasonal variations have a profound impact on the Martian landscape, driving dust storms, shaping the polar ice caps, and influencing the planet's overall climate. If you're planning a trip to Mars, be sure to pack for all extremes. This planet is notorious for its wild temperature swings, experiencing some of the most dramatic variations in our solar system. During the day, especially near the equator, the sun can heat the Martian surface to a comfortable 70 degrees Fahrenheit. But as soon as the sun dips below the horizon, the thin atmosphere offers little insulation, and temperatures plummet to a bone-chilling minus 200 degrees Fahrenheit. These extreme temperatures pose significant challenges for any future human exploration of Mars. Our final stop on this Martian adventure takes us to the planet's poles, where we find another intriguing feature: ice caps. Unlike Earth's ice caps, which are composed entirely of water ice, Mars's polar caps are a mixture of water ice and dry ice, frozen carbon dioxide. Imagine a landscape covered in a thick layer of white, but this isn't your typical snow. This is dry ice, frozen carbon dioxide, that blankets the Martian poles during the long, cold winters. As temperatures drop, carbon dioxide from the atmosphere freezes directly onto the surface, forming a layer of dry ice that can be several miles thick. But beneath this layer of dry ice lies something even more intriguing: water ice. Scientists estimate that the Martian polar caps contain enough water ice to cover the entire planet in an ocean hundreds of feet deep if it were to melt. For decades, humanity has sent robotic emissaries to Mars, seeking to unravel its secrets and pave the way for future human exploration. From the early flybys of Mariner 4 to the rovers traversing the Martian surface today, each mission has added a new piece to the puzzle, expanding our understanding of this enigmatic world. One of the most iconic missions, the Viking landers, touched down on Mars in the 1970s, providing our first close-up views of the Martian surface and conducting experiments to search for signs of life. Then came the Sojourner rover, a small but mighty explorer that captivated the world with its images of the Martian landscape. Following in its tracks, the Spirit and Opportunity rovers embarked on epic journeys, discovering evidence of ancient water and pushing the boundaries of our understanding of Mars' past. Today, the Curiosity and Perseverance rovers are actively exploring the Martian surface, equipped with advanced instruments to study the planet's geology, climate, and potential for life. Thanks for joining us on this Martian adventure. From its towering volcanoes to its ancient riverbeds, Mars stands as a testament to the power of nature and the endless possibilities that await us in the cosmos. As we continue to explore our celestial neighbor, who knows what other secrets we'll uncover? Perhaps one day, humans will walk on the surface of Mars, not as mere visitors, but as explorers, pioneers, and settlers. Stay tuned as we continue our journey through the solar system.